The pull request is ready before lunch. That is the AI coding agent story everyone wants to tell. A developer opens an issue in the morning. Let's call her Nina. The ticket looks ordinary. Update the dependency, clean up a small compatibility issue, add the tests, and open the pull request. So Nina points a coding agent at the repo. The agent reads the surrounding code. It proposes an approach. It writes the first version. It generates tests. It explains the diff. And it opens the pull request. Work that used to take a day now takes an hour. The demo looks great. The tests pass. The pull request is clean. And then it waits. It waits for an environment that has not been provisioned. It waits for access to a service account. It waits for a dependency review, security findings, test data, architecture approval, compliance evidence, and the release window. The code moved quickly, but the enterprise did not. That is the part of the AI coding story that gets much less attention. AI did not remove the bottleneck. It moved it. Hi, my name is Vlad Stanovsky. I write The Sovereign AI Enterprise, where I look at what happens when AI moves from answering questions to participating in enterprise work. And in software delivery, that shift is already here. Coding agents can make implementation faster, but the release path is where the real constraint shows up. Nina's pull request is the point. The code exists, but that does not mean the software can ship. Software reaches production through controls, handoffs, evidence, ownership, and operational acceptance. Some of that is technical. The pipeline has to run. The scan has to clear. The deployment policy has to be followed. There has to be a rollback plan. And some of it is organizational. Someone owns the system. Someone approves the change. Someone accepts the risk. And someone supports it after release. That is the part coding agents do not automatically solve. Because in a large enterprise, the release button has relatives. Security, architecture, compliance, operations, finance, and sometimes a meeting next Tuesday. That sounds annoying until the software touches clients, employees, regulated data, critical infrastructure, revenue, or business continuity. A bank cannot treat a credit risk change like a personal script. A healthcare platform cannot ship a dependency upgrade without knowing what patient workflow it touches. And an airline cannot modernize a scheduling service without understanding downstream systems, batch windows, and operational fallbacks. So yes, the coding agent helped Nina. But now, more pull requests are arriving, more fixes are being proposed, and more modernization candidates are showing up. The same security, platform, architecture, compliance, and operations teams still have to decide what is safe to release, what needs more evidence, and who accepts the risk. The first surprise of AI coding may be that the developer gets faster and the enterprise feels slower. That is where the category starts to change. Most AI software tools are still evaluated at the coding surface. Which tool writes the better function? Which one understands the repository faster? Which one produces cleaner tests? And which one fits the best inside the IDE? These are all good questions, but they measure the part of software delivery closest to implementation. That is the coding assistant category. A coding assistant lives inside the developer loop. It helps inspect the code base, modify files, generate tests, explain errors, and prepare the pull request. Its world is the repo, the issue, the surrounding code, and the immediate result. A useful category, but also a limited category. The next category is agentic SDLC. By that, I mean AI systems that help software work move across planning, coding, review, testing, security, release, modernization, and operations. The coding assistant helps answer one question: can I make this change? Agentic SDLC has to answer a harder one: can this change move safely to production? Let's go back to Nina's pull request. If it is a small internal fix, maybe normal tests and review are enough. But what if the dependency touches authentication? What if the service is used by a client-facing workflow? And what if the change affects how data moves into a payment process? Now, the PR is not just a code change, it is a delivery decision. An agent working across the SDLC needs enough context to know what kind of change this is, where risks enter, which controls shape the path forward. That means it should do more than open a pull request. It should classify the change, surface affected services, attach relevant security findings, identify the approval path, check release readiness, and capture the evidence the next reviewer will need. Because a well-written patch can still be blocked. It can pass unit tests and still miss a dependency. It can modernize a local component and still break a downstream workflow. It can close the issue and still fail the release process. That is why the enterprise evaluation cannot stop at code quality. The stronger system understands the route from change to production, not only the code inside the pull request. And that brings us to the layer people do not talk about enough: the harness. The model gets most of the attention because the model is the visible intelligence. It writes the function, it explains the error, it drafts the test, and it proposes the fix. That is the part we can demo. But enterprise delivery depends on what surrounds the model. The agent needs a harness, the operating layer that determines what it can see, what it can touch, what it must check, and what record it leaves behind. The harness connects the model to the delivery system without letting the model become an unmanaged actor inside it. It includes context, permissions, workflow state, policy checks, CI/CD integration, evidence capture, evaluation, logging, and audit. Nina's coding setup can run with a light harness. The agent sees the repo. It follows a few local instructions. It calls a command line tool. Nina catches what is missing, but Nina also supplies the institutional memory. Which shortcut is safe? Which test actually matters? Which service is fragile? Which reviewer will care? And which deployment pattern has caused trouble before? But enterprise SDLC cannot depend on every developer carrying that much context in their head. The harness has to carry enough of the delivery system to make the agent useful beyond code generation. A stronger model may produce a cleaner patch. It may explain the diff more clearly and generate better tests. But if the harness cannot connect the work to dependency posture, security review, release readiness, change records, rollback planning, and operational handoff, the agent is still producing output at the edge of the delivery system. The model may produce the patch, but the harness determines whether the patch becomes controlled work. Modernization makes this obvious. Imagine Nina's next ticket is not a small fix. It is part of a modernization effort. The agent can translate a function, update a syntax pattern, explain an old class, or draft the first pass of a migration. That is pretty useful. In old code bases, even basic comprehension has value. Many enterprise systems contain logic that survived multiple owners, expired documentation, uneven naming conventions, and years of urgent fixes. But modernization rarely fails because one function could not be rewritten. It fails when the rewritten code changes behavior the enterprise did not understand. A Java upgrade can change a serialization pattern that a downstream service quietly depends on. A framework migration can alter an authentication flow that behaves differently under production traffic. And the dependency replacement may pass unit tests and still break the month and batch job. Mainframe modernization can produce cleaner code while stripping out the operating assumptions that made the old system safe to run. That is why the opening pull request waits. The enterprise has to know what the change connects to, which systems depend on the current behavior, which tests prove equivalence, who owns the cutover, what rollback path exists, which operations team needs to prepare, and what evidence will satisfy audit, resilience, and risk. The coding work may be the most visible part of modernization, but it is rarely the whole job. Modernization is controlled change, not translated syntax. This also changes how we should think about governance. A coding agent can be governed at the moment it acts. The enterprise can control who invokes it, which repository it can reach, what tools it can call, which logs are captured, and which actions require approval. Those controls are important, but SDLC risk does not end with agent action. Nina may be authorized, the agent may have permission, the repository access may be approved, and the logs may show exactly what happened. But none of that proves the change moved through the right delivery path, because the risk lives in the change itself. A UI text change, a dependency upgrade, and a modification to an identity workflow may all begin as code changes. They should not move through the same controls. One may need tests and review. Another may require vulnerability evidence, architecture review, operational sign-off, or a release window. A third may need stronger scrutiny because it changes how access is granted, logged, or revoked. Runtime governance records the agent's action. SDLC governance records whether the change passed the controls required for its risk. That distinction is key because faster code generation pushes more unfinished decisions into the same review queues. If governance stays concentrated only at execution time, the enterprise may see what the agent did while still lacking the confidence that software is ready to ship. The change record should not become a reconstruction exercise after the release. Otherwise, the useful context scatters across tickets, pull request comments, chat threads, and meetings. Then, someone has to rebuild the story later, usually under pressure, and usually after the decision already mattered. So the answer is not to help agents route around enterprise controls. That just creates faster shadow IT, more code, more undocumented exceptions, more release pressure, and more risk pushed downstream. The better goal is to make the governed path easier to complete than the shortcut is to clean up. Let's go back to Nina's pull request. The code is ready before lunch, but the work is waiting on environment access, dependency review, test data, security findings, architecture approval, compliance evidence, or a release window. An agentic SDLC system should make those blockers visible while the work is still moving. It should recognize that the change touches a payment service, identify affected downstream systems, attach relevant vulnerability findings, prepare the change record, generate the test evidence request, find the right approver, and explain why the release path is blocked. Governance shows up before the pull request reaches the final queue. Nina does not have to chase 5 systems to understand why the work is stuck. The security reviewer does not have to reconstruct context from a diff and a vague ticket. And the compliance team does not have to assemble evidence after release, when the useful details have already scattered. So the best governance experience is not a bigger form. It is fewer scavenger hunts. For routine changes, the path can be lighter. Confirm ownership, run tests, attach evidence, and move the pull request forward. For sensitive changes, the path can require more evidence, clearer escalation, and explicit risk acceptance. The value is that the path becomes visible, risk-adjusted, and harder to bypass. Because if the workaround is faster, people will use the workaround. Enterprise software delivery will not get meaningfully faster until the control path becomes easier to follow than the shortcut. And once agents become part of that path, they become more than productivity tools. They become infrastructure. An agent embedded in the SDLC starts to learn how the enterprise builds software, which systems are fragile, which reviews matter, which exceptions recur, which teams own the risk, which release paths are trusted, and which evidence has to exist before a change can go live. That delivery memory has to live somewhere. If it disappears into one agent surface, the enterprise loses more than prompts or chat history. It loses release logic, approval patterns, policy interpretation, modernization history, and the record of how risk was accepted. That may become the quiet lock-in story of agentic software development. And this is where the shared agent problem becomes concrete. Once agents become shared, personal behavior can become institutional behavior. In software delivery, that behavior can shape how code is reviewed, how modernization happens, how exceptions are handled, how releases move, and how risk is accepted. Nina's pull request was ready before lunch. But that was never the whole story. Shipping still depends on whether the enterprise can trust the path from change to production. And that is where the next software contest moves. From who can generate the most code to who controls the path from change to production. I wrote the longer version of this argument in this week's edition of the Sovereign AI Enterprise. The link is in the description.
The data flows, a constant stream, shaping futures, chasing every dream. Complex patterns and sights unseen, a new era, sharp and keen. The world is changing, can you feel the pulse? A deeper vision beyond every impulse. Enterprise, geopolitics, AI.